This is the second video of the No Nonsense Technician Class Study Guide. We're starting off on the diodes section. So question T6B02, what electrical components what electrical component allow current to flow in one direction? That is a diode. B09, T6B09, what are the names for electrodes of a diode? Anode and cathode. Anode and cathode are the names for the electrodes of a diode. T6B06, how is the cathode lead of a semiconductor diode often marked on a package with a stripe? How is a cathode lead of a semiconductor often marked on the package? Remember, there are two electrodes in a diode, so the cathode lead is marked with a stripe and the anode is not. T6B01, which is true about forward voltage drop in a diode? It is lower in some diode types than others. Which is true about forward voltage drop in a diode? It is lower in some diode types than others. T6B07. What causes a light emitting diode, LED, light emitting diode, to emit light? A forward DC current. Forward DC current. Which of the following is commonly used as a visual inductor? LED. LED is used as a common visual indicator. Not inductor. Apologize. So, next we are going into transistors. Transistors T6B03. T6B03. Which of these components can be used as an electronic switch? A transistor. What is the term that describes a device's ability to amplify a signal? Gain. Gain on your microphone. Gains is the same gain that is put into your radios as well. Which of the following can provide power gain? Power gain. Transistors provide power gains. T6B04. Which of the following components can consist of three regions of semiconductor materials? Transistors. Transistors consist of three regions of semiconductor materials. What are the names of electrodes of a bipolar junction transistor? Emitter, a base, and a collector. What does the abbreviation FET stands for? FET. FET. What does it stand for? Field effect transistor. Field effect transistor. What type? T6B05. What type of transistor has a gate, drain, and a source? A gate, drain, and a source. Field effect transistors. All right, circuits, diagrams, schematics, symbols, component functions. T6C01. What is the name of an electrical wiring diagram that uses standard component symbols? Schematic. Wiring diagram is a schematic. Which of the following is accurately represented in electrical schematics? Component connections. Component connections. Okay, you're going to come across a few figures, diagrams on your test. So this is one of the figures, one of the diagrams. All right. So in figure T1, what is component 1? This is component 1 right here. Okay. Component 1 is a resistor. It kind of goes in and there's a little resistance, and then your current keeps going that way. All right. Number 1, component 1 is a resistor. Component 2 in T1, figure T1, is a transistor. Component 2 is a transistor. All right. There's not really an easy way of remembering this. Just memorization is really the best thing that I could tell you. How I remembered them was to actually draw them out on a little notebook and draw each and every single one of these diagrams, okay, and figure out just what they are by memorization. There's not really a trick to it. All right, so T6D10, what is the function of component 2 in figure T1? Component 2. So a transistor we're talking about. All right, we're talking about a transistor. Component 2 is a transistor. So what does a transistor do? It controls the flow of current. Transistors control current flow. All right, component number 3. Component number 3 is a lamp. So let's go look up here. See, it kind of sort of almost looks like a little tiny LED kind of, well, not really LED, but kind of an indicator. All right. Kind of looks like a lamp, kind of looks like a light bulb, sort of. That's the way I remembered it. All right. Lamp T6C05. What is component 4 in figure T1? That is a battery. This is a symbol for a battery, a power source of some sort. Well, one of the power sources. You got power coming through here, and it's getting grounded. This is ground. It's getting grounded here. This is the negative, and then it's charging a battery from the looks of it. All right, so T2. This is T2. It gets a little complicated. It's okay. Don't let it discourage you. You know, just draw them out on a little piece of paper. All right. What type of switch is represented by component 3 in T2? Single pole, single throw. Component 3. Component 3. Single pole into a single throw switch. All right. Component 4 in T2 is a transformer. Component 4. This is this kind of looks like a transformer, to be honest with you. If you Google transformer images, that's almost exactly what a transformer looks like. Okay, you got these coils going on both sides, and you got the current flow going through the middle of those two coils. All right. So we are on T6D06. What component changes 120 volt AC power to a lower AC voltage for other uses? A transformer. Okay, so current, it could be 4 to 1, 4 to 2, 2 to 1. Excuse me. Like a 2 to 1 transformer would be, let's take this example. If you put 120 volt through a 2 to 1 transformer, so that would mean 120 volts going in here on this end, and then if this is a 2 to 1 transformer, it would be going by the time it comes out, it's going to be half, so it's going to be at 60 volts. All right. Same thing. If it was a 4 to 1. If it was 4 to 1, we would be dividing the voltage by 4. If it's a 2 to 1, we would divide the voltage by half. All right, T6. We're going into component 5 in figure is diodes. We're going into diodes and all that kind of good stuff. All right, so T6D01. Which of the following devices or circuits change in alternating current into a varying direct signal? Rectifier. Rectifier. What is component 6 in figure T2? Component 6 is a capacitor. So this is a capacitor. All right, straight line with a parentheses, kind of a, a frowny face. Okay, yeah, let's go with the frowny face. Straight line with a frowny face symbol, I think, kind of, sort of. All right, T6C07. What is component 8 in figure T2? Component 8 is an LED, light emitting diode. Component 8, yes, component 8. So let's go back up here. This is a symbol for an LED, a light emitting diode. All right, LED we just talked about. What is component 9 in T2? A variable resistor. Component 9. Component 9 is a variable resistor. If we look up here, this is a symbol for a resistor. Okay, you see, it's just those wavy line that sort of look like W's or M's. Okay, if we look down here, you got the same symbol, but you got a little leg that comes out from one of the symbols. All right, so when you add this little leg in there, it becomes a variable resistor. All right. So this is T3, figure T3. What is component number 3 in T3? A variable inductor. Component 3. So this is an inductor. Okay. Kind of half of a transistor. Transistor? Let me make sure. I don't tell you. Number 4. Yeah, transformer. I'm sorry, not transistor. Transformer. So a variable inductor. Okay, it's pretty much like, it looks like half of a transformer. All right. What is the component 4 in T3? That's an antenna. Component 4. So this little triangle, okay, with the line going through it, is your antenna symbol for the antenna. All right, kind of this shape of an antenna would be considered a delta loop. Okay, if you were to build an antenna exactly looking like this in a triangular shape, all right, it is called a delta loop. There are lots of different variations of loops. You can make it into a square. You can make it into like a round if you want. But this, when you go into this triangular shape, okay, That is the Greek letter for delta. All right, so it is known as delta loop. So that's how I remembered it. Okay, this is a delta loop antenna, this shape. All right, so that is why that's how I remembered that figure is an antenna. Next section is resonant or tuned circuits. Question number T6. D11. Which of the following is a resonant or a tuned circuit? An inductor and a capacitor in a series or parallel. Inductor or a capacitor in a series or parallel circuit. T6D08. Which of the following is combined with an inductor to make a resonant circuit? Which of the following is combined with an inductor to make a resonant circuit? Remember we said an inductor, a tuned circuit has an inductor and a capacitor. So it's telling you, it's telling you that you already have an inductor. So what are you going to add to an inductor to make a resonant circuit, which is a capacitor? Other components. T6A08. What is the function of an SPDT switch? A single circuit is switched between one of two other circuits. Single pole dual throw. Single pole dual throw is SPDT. What is a relay? What is a relay? An electrically controlled switch. Electrically controlled switch is a relay. Which of the following displays an electrical quantity as a numeric value? A meter displays an electrical quantity as a numeric value. T6D09. What is the name of a device that combines several semiconductors and other components into one package? Several components into one package. An integrated circuit. Integrated circuit. What is T6D05? What type of circuit controls the amount of voltage from a power supply? Controls being the operative word here. What controls voltage in a power supply? A regulator. It regulates the amount of voltage from a power supply. T6A09. What electrical component is used to protect other components from current overloads? Current overloads. A fuse. Just like a fuse that's in your home, in your car. All right. If you normally your cigarette lighter is around 10.3 volts, if I'm not mistaken. I could be wrong. I think it's 10.3. So if you try to hook up your radio, your ham radio, let's say a VHF, UHF radio, which requires 12, actually it's more like 13.4 volts into the wiring of a cigarette lighter, it's going to blow the fuse. Okay, because it's pulling 12, at least 12, most of the time 13.4 volts. And that circuit, the cigarette lighter circuit, is designed only for 10.3 volts. That is why you should never wire your radio via your cigarette lighter, via the accessory socket, accessory wiring. All right, you should always run a power cable, positive and negative, through the wire, the firewall of your vehicle, directly to the battery. That's the best way to do it. It knocks out a lot of the power, the noise that's going to be coming from the alternator and other electrical equipments that is in your vehicle. It'll knock all that out as well. T6D03, which of the following is a reason to use shielded wire to prevent coupling of unwanted signal to or from the wire? All right. Radio wave characteristics: frequency, wavelength, and electromagnetic spectrum. Excuse me. T3B03. What are two components of a radio wave? Electric and magnetic fields. T3B01. What is the relationship between the electric and magnetic fields of an electromagnetic wave? They are at right angles. Radio waves travel at the speed of light, 300 million meters per second. Okay? What is the velocity of a radio wave traveling through free space? It's the speed of light. What is the approximate velocity of a radio wave in free space? 300 million meters per second. All right, lots of mathematical formulas here to calculate. Not really necessary to remember all these things, but they're there for your information. T3B06, what is the formula of converting frequency to approximate wavelength in meters? Wavelength in meters equals 300 divided by frequency in megahertz. All right. So 300 in frequency divided by 300 divided by the frequency in megahertz. All right. Where are we at? T3B05. What is the relationship between wavelength and frequency? Wavelength gets shorter as frequency increases. So as you go up to 2 meters, 70 centimeters, the actual wavelength is getting shorter and shorter and shorter. And as you come down, it'll get longer and longer. You know, your 20 meters is going to be a lot longer than your 2 meter band frequency. So that's why you need bigger antennas the lower you go in the band. So T3B07, in addition to frequency, which of the following is used to identify amateur radio bands? The approximate wavelength in meters. Just like what I was saying, 2 meters, 70 centimeters, 20 meters. That's the approximate wavelength in meters. All right, that's how we refer to the bands, is by the length of the wavelength. T3B10. What frequency range is referred to as HF? HF, high frequency. 3 megahertz to 30 megahertz. All right, so you're all the way up until your 10 meter band. All right, all the way from 160 meter to 10 meter is considered HF. What frequency range is referred to as VHF? VHF. 30 megahertz to 300 megahertz, which includes your 6 meter and your 2 meter band. UHF is after 300 megahertz, 300 to 3000 megahertz. All right, really, really small antennas in the UHF area. So T5C06, what does the abbreviation RF mean? Radio frequencies, signals of all kinds, all types and kinds. Radio frequency, RF. Propagation modes. Why is the radio horizon for VHF and UHF signals more distant than the visual horizon? The atmosphere refracts radio waves slightly. All right. VHF and UHF signals are normally considered a line of sight signals. You know, if you can see somebody, you can talk to them, but that's not always the truth. All right, they go a little bit beyond that, because, like that question says, the atmosphere has a little bit of something to do with it as well. Why are simplex UHF signals rarely heard beyond the radio horizon? UHF signals are usually not propagated by ionosphere. All right. So, radio frequency, radio waves are a bit tricky. You know, some areas, some signals, some frequencies will get refracted. Some frequencies and signals will get absorbed. All right. So T3A01, why do VHF signal strength sometimes vary greatly when the antenna is moved only a few feet? Multipath propagation cancels or reinforces the signal. Like I just said, it's a very, very tricky business. All right. Few feet, few inches in some cases can make a whole world of difference. There's a great saying in ham radio that height is might. Okay, when it comes to VHF and UHF signal, that is the absolute to God truth. Okay, the taller you can get, the taller that you can get your antenna, the better signal you're going to have. More people you're going to be able to reach. You're going to be able to receive a lot better signals. That is why repeaters are normally around 200 feet. All right, above water towers, so they have a greater line of sight than anything around them. T3A06, what is the meaning of the term picket fencing? Picket fencing. Rapid flutter on a mobile signal due to multipath propagation. So if you take a little stick or something and you got a picket fence, and you take a little stick and you're running across the picket fence, you get that. Okay, that's kind of sort of what that means. You know, you'll get a rapid flutter on a mobile signal due to multipath propagation. So it's going in one direction, bouncing off, and going into another direction, maybe not bouncing off, you know, and maybe going into a third direction and bouncing off from there. So you're getting like, you know, different radio signals all coming in. What effect does T3A10, what effect does multipath propagation have on data transmissions? Error rates are likely to increase. So, you know, same thing. Voice, you can compensate a lot. Data, you know, they're computers talking back and forth. So if they're getting multiple signals, they're not going to like it. T3A05. When using a directional antenna, how might your station be able to communicate with a distant repeater if buildings or obstructions are blocking the direct line of path? Try to find a path that reflects signals to the repeater. You can bounce signals off of buildings. You absolutely can. All right. So maybe moving like a half a mile, quarter mile in a certain direction might change your reception to a repeater. Okay? Because you're bouncing it off of a specific building. All right. Which of the following T3C05, which of the following effects may allow radio signals to travel beyond obstructions between the transmission and receiving signals? Knife edge diffraction. All right. Sometimes signal can knife right through a building. All right. Very, very radio frequencies and signals, very, very tricky things, and they're very fun to play with, to be honest with you. T3A02, what is the effect of vegetation on UHF and microwave signals? Absorption. So when it's springtime, summertime, springtime, your propagation on UHF is not going to be that great at all. All right. Thank you very much for joining, and we will continue this at a later date.